Okay, here are the last two reactions that you have. Part one was over combustion, synthesis, and decomposition reactions. These last two are called single replacement and double replacement. So with single replacement, that's the first one. How you're going to know it's single replacement is you're going to have a single element here on the reactant side added to a compound, okay? What's going to happen on the other side is if this single free element, they're going to call it the free element, if it is a metal, then it will replace the first element in the compound because we know the metals go first. If this free element is a non-metal, then it is going to replace the second element in the compound because the non-metals are generally second, especially in ionic compounds. So remember, metal replaces metal, non-metal replaces non-metal, okay? And we're going to have to look up to see if this free element has a greater activity series. I'm going to show you that in a second to be able to kick this one out of the compound, okay? Here's an example. Copper is our free element, all right? And AgNO3 is our compound. I know this is single replacement because it has a single element, plus a compound, all right? And look what happens. Copper goes in, copper's a metal, all right? So it goes in and replaces this metal, all right? Silver, you see silver's kicked out over here. Copper has went in and bonded with nitrate. And over here we have copper to nitrate. Now, to be able to tell if this reaction will happen and copper will actually go in and replace silver, you have to look on this activity series. Okay, I'm going to give you one of these today, and here is the activity series. This is used for single replacement reactions. You may want to make a note on yours when you get it that the activity series is what you use for that. So here's copper right here, and then here's silver. You see copper is higher on the activity series than silver. That means it will replace it. So let me repeat that. The free element has to be higher on the activity series to replace the one in the compound. If it is not, then that reaction will not happen and you will simply put an NR after it. Okay, so copper was higher. That means it goes in, it bonds with nitrate instead and kicks silver out over here. Single replacement. Okay. Okay, free element must be more active. There's those notes, okay? So again, if you go look up, first of all, I know this is single replacement because I've got a compound plus a free element, okay? If my free element is higher than copper, iron is. You go look at that sheet that you have and see that iron is higher than copper. Copper's getting kicked out. Iron's going to go in and bond with sulfate instead. Now, here's an example of one that is not, and I'm going to have you add, well, you actually don't even have to add these nonmetals. You notice that bromine is a nonmetal, not a metal. That means it will replace the second in the compound, not the first, because it's a nonmetal. They replace the second one, okay? Now, the activity series of these nonmetals is perfectly aligned with the periodic table. So if you look on the periodic table in group 17, you have fluorine, chlorine, bromine, iodine in order. That's also their activity series. So fluorine is the most active, then chlorine, then bromine, then iodine. So if you look at that, bromine is not higher than chlorine. He's lower than chlorine on the activity series. So that means bromine would not replace chlorine. And if that's the case, you just put NR, no reaction. Okay, if bromine was higher than chlorine, it would go in there, kick out chlorine, and on here over here you would have NaBr plus Cl2 if it was higher, okay? And so what we'll do is, this is the best way to show you that, because I know I said that and some of you may still have a little hard time understanding that. Let's go ahead and out beside here, we'll just list them. So on this activity series, and you can just list them right beside it because this is how they increase with that arrow. Fluorine would be on top, then chlorine, then bromine, and then iodine. So here are your nonmetals and their increasing activity. They go right along with this arrow, okay? That's just the same way they appear on the periodic table as what I was saying before, okay? So that's how your nonmetals go. All right, one more. All right, for double replacement, how I'm going to know it's double replacement is I'm going to have a compound plus a compound. See, I've got compound plus compound. It's the only one like this, all right? And what they're going to do is they're just going to change partners, okay? So A would go bond with D, C would come over here and bond with B, all right? They're just going to change partners. I know this is a double replacement reaction because I have a compound plus a compound. That's how you know. Now look what's happening on the other side. Lead, or Pb, has came over here and bonded with chromate. There it is right there. And then K came over here and bonded with NO3. There it is right there. So they just change partners and then to make the products, okay? Now you notice these S and this AQ. You are going to have to be able to look up if it's a solid or aqueous on the other side. And so I'm going to show you how to look up those solubilities because when you write these products, you're going to need to put either an S or an AQ. It's going to be one or the other, okay? All right, so if this is our equation that we have that we need to write. Okay, so what's supposed to happen is lead is going to go bond with iodine, okay? K, potassium, is going to come bond with nitrate. All right, so what you have to do is look at your solubility chart, and that is right here in the middle, okay? In the middle is a solubility chart. So we said that lead was going to bond with iodine. Well, there's iodine right here, and I can undo these. So let me just go ahead. Here's iodine right here. All right, and iodine is soluble. That means it's going to be aqueous, okay? Soluble. Unless it's bonded with any of these. Well, look, there's lead right there. That is an exception. So normally iodine soluble unless it's bonded with lead. Ours was, remember, our lead was going over to bond with iodine. It would have been PbI2. Okay, that was the compound that was going to be made. So this one would be a solid because it would be insoluble. Okay, soluble are all these. These are exceptions which make them insoluble. Okay, down here, these are all insoluble, which most of the time they form solid compounds unless they're bonded with these. These are exceptions that make them soluble. All right, the other compound that we were making over there was KNO3. All right, so if I go look up NO3, look, anything bonded with NO3, here it is right here, ever, is soluble. So it doesn't matter. There are no exceptions. So if it's got NO3 in it, that thing is always going to be aqueous because aqueous is soluble. Insoluble will be solid. So you are going to need to label these when you do these. Okay. And let me see if I can go back so that when we do the next one, all this isn't there. Okay. And so I think I have one more example. Find my, okay. And I'll just leave it here. So here's the next one. I know this says NR, but I'm not going to have you write NR. I'm going to have you put their states after them because that says a lot in itself. So if you have NaNO3 bonding with Ki again. So look, you can clearly see that K is coming back over here to bond with NO3. Okay. That means you know that one's going to be soluble. We just looked that up. Okay. So one of them is AQ. The other one is sodium coming to bond with I. So let's look. Here's I again, okay? Except this time I is soluble and it is not bonding with an exception. Sodium is not one of those exceptions. So that's going to make both of those AQ. So instead of writing NR, I would want you to write the products of that as NaI AQ because it's soluble plus and then KNO3 again AQ because it's soluble. So I want you to go ahead and write those products out and just put their states after them depending on if they are soluble or insoluble.